So, again, proof two triangles are congruent. Two angles from one triangle have to be congruent to two from the other. You only need two because you don't need the third. The third one would have to be whatever number it is to make it all 180. Okay, questions? You have any questions so far? Now, the examples that we're going to be doing are basically, you're going to have to sometimes find the third angle from one triangle to prove that two triangles are congruent because of the AA, angle postulate. Again, your similarity is that little tilde looking mark. All right, here we go. Go to the first page. Okay. What do we know? If we look at both of our triangles, is there at least one angle that matches with both of those triangles? Is there one angle measure that you see the same in both? We look at our two triangles. Is there at least one angle measure in the little triangle that's congruent to one angle measure in the big triangle? Which one? You could tell us. Huh? Well, J. Okay, we don't see 45 yet. We do see L and X have an 85. So there's at least one angle right there. Boom. Boom. Okay, we see a 45 in one triangle, 50 in the other. Well, do these match? Are these congruent? No. However, what do we need to do either in this triangle or that triangle? What do we need to do? What do we always need to do?
Add them.
Well, you could add them. So, let's see. What's 85 and 45? Add them up. What do we get? Your calculator's right in front of you. 85 and 45 is 130.
I subtract it from 180.
Yes. Very good, Dennis. 180 minus 130. So who can tell us what 180 minus 130 is? 50. Very good. Thank you, Andrew. We found out that angle K is 50 degrees. Now, we have a 50 degrees here. Do we have a 50 degrees in our second triangle?
No.
Second triangle.
No.
You can do that too. You can do that. So 50 plus 85, 135. Okay? And then you said take it away from 180, right?
Yeah.
180 minus 135 is how much? 45. $45. So angle Y is 45 degrees. I think that's better for everybody. Well, at this point, do we see at least two angle measures from one triangle congruent to two angle measures from the second triangle? Yeah or no? We do. So sometimes we may have to find that missing angle measure from either one or the other triangle. So in this case, these two triangles, LJK and XYZ, they're going to be similar because of the angle postulate. Because in the angle-angle postulate, these two triangles will be similar. The reason being, they have an 85. Well, we found out that, okay, they also have a 50, or they have a 45. But at least two of our angles from one triangle match two angles from the other. Any questions so far? There's a lot of, because that's what you probably need to do in many of these cases. You may not always see the third angle right away, but you're going to have to do some math to get that final angle. All right, questions before we continue? Okay. Go. Okay. We have 37 degrees and 28 degrees for the smaller triangle.
No, we're doing the same thing we did last time.
Yeah.
28, 65.
Okay.
And then you subtract 180.
Very good. 180. Oops. 180 minus 65. Figure it out. 115. Okay. The missing angle from the smaller triangle is 115 degrees. Or, what about the bigger triangle? You can do the same thing. 28 and 115. 143, and then 180 minus 143. 37. Okay. So again, once we found this angle, or if you found that angle, do we have our angle? Do we have at least two angles from one triangle? Congruent to two from the other? Yeah. Again, there you go. There you go, angle. Questions? Okay, come on. Focus. You need a pencil or do you have one? All right. Whatever you missed, get from a neighbor or classmate. All right. So moving on. All right, this next one I'm gonna redraw the next one. This one gets a little wordy. Now, one of your homework assignment questions, you're going to have something similar. All right, so here's what's going to happen. You have this bow tie looking figure. And I only gave you one of the two possible angle measures, or one of two or three, you could say. So I only gave you. Perfect. So angle R from the first triangle, 45. V is also 45. So now, here's something else. Here's some other information that's probably super important. RSW. Remember, start from the R. Go to S. Go to W.
Do we make that paper?
You can, You don't have to because it's already there. It's on your left-hand side of the words. And B as B. Now, those are the two angles. Who can tell us why these two angles are congruent? Can anybody tell us why those two angles are congruent?
They have the same numbers.
Well, be careful. They have the same numbers here. What about there? The turning point is the key. The turning point is the key. Just because they have the same numbers here, that does not necessarily mean they have the same numbers there. But they will. But who can tell us why? It begins with a V. This is going back to first quarter, maybe second quarter. Say it again. Vertical angles. That's right. They're vertical angles. What do you miss get from the neighbor? These are actually going to be graded notes. You have vertical angles there, ladies and gentlemen. Vertical angles. So these two angles, since they're vertical, have to be congruent to each other. That's an always. Thank you. They're vertical angles. So now do we have at least two angles from the first triangle that are congruent to two angles from the second? Do we have that here? Yeah, Adrian, you're right, we do. Because this 45 is matching with that 45. These two match up. There you go. There's your angle. Because then B and W have to also be the same. There you go. You have another example. Okay, questions? All right. Now the last slide from angle. Next slide. Who thinks they know why this is going to be a non-example once I put it up? Okay, before I get there though, anybody have any questions on this problem here? Okay, do we need that phone? No. Do we need that phone? That is. Okay, class warning is going to be coming into effect. We don't want that. All right. Here we go. So, since the vertical angles, these two are congruent. 45s are congruent. Then angle. Because then B and W also have to be congruent. All right. Because on your homework, you're going to have a problem that looks very similar to what was on number 12. So you're going to have a very similar problem to this one here. All right, real quick, this last one, this is a non-example because, just like before, add them up, subtract from 180. That's what you do. Whatever number you get, it's going to be 180. Minus whatever number you get. 180 minus whatever number you get.
For the first one, for the triangle and the left corner.
Yeah, you can do that. So add 57 and 92. What do you get?
139.
Okay, subtract that from 180. What do you get?
31.
Angle C is 31 degrees. And then, same thing, 41 and 92. You get what, 133?
133.
And then once 180 minus 133.
37.
Okay. So we have one angle that matches. But do we have two angles that match? No. So this is an example. You got to be careful. Some of these problems are going to say they're going to give you one matching angle, but they're not going to give you both. You do need to figure that out. In some cases, you're not going to get. You may not have two angles that match. Okay, question so far. So on your homework, you're going to have a couple problems. So if you just walked in, there was a separate piece of paper, 6 problems for homework. It's due, not next class, but the following class. However, you might be able to take care of it. You might be able to complete it by next class. All right. Questions as we get ready to continue. Got it? All right. Now the second type is the side angle side deal. And here's what's going to happen with side angle side. First, you have to have that angle that forms. But then you also have to make sure, now there's more than one way you can set up this, your little way to determine whether or not you have similar triangles. Because one way you can set it up is by way of your similarity statement. Because the similarity statement, you put A, B, C, remember, you put A, B, C on top of D, E, F, you figure out right away which sides match with each other. So we knew right away, AB is going to match with DE. And AC, AC slightly got cut off here. AC matches with DF. Again, you get that from this similarity statement. Because here, similarity statement is going to basically get you your proportionality statement. That's going to tell you AB is going to match with DE. So the other way you can write it is A. This one, I know in the computer it was more sideways. But with a lot of these, problems, we do the fraction up and down. So it's basically this line was rewritten like this. Now, I'm going to show you one other way you could set up your proportion if you want to make your life a little easier. Here's how you can make your life a little easier. You go back to this problem here. I'm going to show you by way of the diagram. Here's another way you can set up your proportion. Notice where our angle is located, right? Angle A. Here's what you can do. Here's another way to set up your proportion, and it might be easier for some of you. Think about your angle as like a fraction bar. See where I'm forming my fraction bar? So what you could do, you could take this side, AB, you could write it as AB over AC. Similarly, here's your fraction bar. But I'm going to tell you have to be careful when we do it this way. But I'm going to show you why you have to be careful. You could set up your proportion like AB over AC. This is another way you could set up. That could also work. Basically, what happened was, in the end, you switched the order of A, C, and D, E. But in the end, that can still work because when you do your cross multiplication, you're still multiplying the correct sides you need to multiply. Basically, you're multiplying shorter or larger side of the bigger triangle with the longer side of the smaller triangle and vice versa. But yeah, that can work too. That's another way. Usually, I tell everybody, follow similarity rule. Similarity statement, proportionality statement. This usually go this way, route. This is the safer bet. Because if you, reason being, sometimes some of your diagrams could get inverted. So you have to be very careful. I'm going to show you an example. All right, questions before we continue? All right. Yeah, that's okay. I'll look at it later. Thank you. Packet is graded notes. Single piece of paper homework. Whatever you miss, get from neighbor. All right. Let's look at number 15. Okay. This is a little too wordy. We'll make your lives a little easy. That's how we're going to do that. Who could tell us how to name the bigger triangle? Just name the bigger triangle first. How do you want to name the bigger triangle? Anybody? What three letters form the bigger triangle?
TUV.
Okay, that was easy. Okay, so you went the bigger triangle, T, U.
Doesn't matter how you use the letters.
For the first one, no. The second one, absolutely.
So the second one will be UWX.
Bingo. That's right. That's the important one. This one, no. That one, absolutely. But that's a very good question, Dennis. Because now, here's what you have. You can set up your proportionality statement. That's right. So there was more than one way you can do this. Now, this first box, I'm just going to, you can write 0.5, but that's not the only way you can do that. Because in the end, notice how UV and WX, notice how they match. Because you could either put, you put TUV up here, or if you had flipped, you put UWX. You can do it that way too. Don't worry so much about this one, but what you did, Dennis, was more important. You got the, once you named that first triangle, you knew exactly how you had to name the second triangle. That's the most important part, because you also knew which sides had to match. He knew that UV, which I'm going to highlight in a second, He knew UV had a match with WX. Boom. He knew those two had a match. He also knew that TU matched with UW. You got that part too. And then by process of elimination, NTU VT also had a match. So he knew who had a match with who. Once he named that first triangle, he knew how to match the second one. And again, there's more than one way you could set up your proportion correctly and get a correct answer. Now, it just turned out by luck, we matched the sides. We matched WX, UV. That's how we matched that first one. That's where we get the 5/10. And then I think similarly, XU over VT, 14/28. Now, another thing we know. Now, in both cases, if you check 5 divided by 10 or 14 divided by 28, use your calculator, check it out. See what number you get in both cases. So, 5 divided by 10 or 14 divided by 28. What do you get in both cases? You get 0.5 in both cases. So, okay, these sides are going to be proportional to each other. Now, I'm going to show you one other way. But the deal is, again, you have to make sure you're matching your sides correctly. The other way you could have done it. What if we did 5/14 and then 10/28? What do we get in both cases? Do we get the same decimal in both cases? If you did 5/14, 10/28, would you get the same decimal? You would. That's another way you could check whether or not your two sides from one triangle are proportional, two sides from the other. So there's more than one way we can get this correct. I usually say go by the similarity statement. But you sort of have the same thing here because in the end what happened was they just flipped the 10 and the 14, but you're still going to get the same result. All right. Now the other thing we know, angle V and angle X, why are they congruent to each other? In that middle box, what do we know about those two angles, V and X? They are both, there's notes, okay? They're both how many degrees? 90. So there's your angle. And it turned out this side are congruent. This side are, similar, I should say. So these two triangles are similar because the side, the angle between the two sides, and the other side from one triangle is proportional to the other. So that's one way you can get an SAS out of this. Your side proportional to your side angle is congruent to the angle, and then the other side forming that angle is proportional. Same proportion, of course. But that's how you can tell whether or not you got proportional triangles. corresponding side from one has the same proportions. But again, use your similarity statement to help you determine whether or not your sides are proportional to each other. Any questions up to this point? We're going to try another one. And again, the proportion that is on your paper may not necessarily be the only one you need. Again, there's more than one way you can set up a correct proportion. All right, questions before we continue? Because the next problem is going to be similar. The paper listed one way, but that's not the only way you can get your proportion. All right, if we're ready, we're going to go to the next problem. Again, a lot of this is practice. Practice. Once you see it, boom, you got it. Okay. Don't look at the first line yet. Here's what I want us to do first. Before you do that, let's figure out, how do we want to name these triangles? Who can name us the first triangle? Anybody. The triangle on the smaller one, the one on the left. Who wants to name it?
LMK.
LMK? Okay, we can do that. Or MLK. Who said it first? I forgot. One of you two said it. You both were right. All right, so we'll go. No, we'll do MLK. Let's do that first. Now, if the first triangle is MLK, we want to figure out if it's
RCP.
have to do RQP. Very good. And this one you can kind of see because you can tell already. Larger side, angle, smaller side. Larger side, angle, smaller side. Then, of course, put MLK over RQP. Boom. There you go. There's your proportionality statement because you can tell right away. ML. RQ. And then similarly, LK. I know that's written slightly different, but you're going to get the same results in the end. QP. Did you get that from here? Here is where you get this, and then I think you would also get KM. KM over PR. Okay, so there's your proportionality. Now, we're not going to use KM or PR because do we know what the lengths are for KM or PR? Do we know those lengths? KM or PR? KM. No, we don't. PR doesn't have a number, so really, sorry about that. So in the end, we really don't need this one. We just need the other two. So in both cases, well, and again, the one way I'm going to show you is not the only way. Because ML, how long is ML? What's the length from M to L?
7.5.
7.5. Over, what's the length of RQ?
12.
Okay. You have 7.5. Over 12. Now, LK, how long is LK? QP.
8.
Now, two ways you can figure this out. You simplify. You get the same check to see if you get the same decimal. That's one way you can do it. 7.5 divided by 12, or 5 divided by 8. What do you get in both cases? Okay, check those calculators. I'm not doing that enough here. I see a lot of closed calculators. 0.625. Do you get that in both cases? Yes, you do. Now, the other way you could have done it. 7.5 over 12, do your cross multiplication. 5 over 8. Boom, do your crisscross. You should get the same number in both cases, which is 60. That's the other way you could have done it. All right. So do we agree? These two sides from the first triangle are proportional to the two sides of the second triangle. We agree, they're proportional. All right. Two sides definitely work. What about that angle? They said that angle Q and angle L are congruent. How do we know they're congruent?
Because they have the little thing.
Okay, that little thing is called there. You said it. Say it louder.
No, I forgot.
Oh, you forgot. I thought you said it. Sorry. Okay, they have the same single, begins with an A. Well, it's an angle, but what's that little thing called? It's a 3-letter word. Arc. It's an arc. Yep, single arc. Or you can say single ring. That's fine too. So we have the angle. So with the SAS, side angle side, would that work for this problem here? Yeah, that would work. That's a side angle side.
So what does that say? Single ARC?
Yep, arc. ARC is arc. That's that little ring that. Okay, questions? Again, the other way you could have done it, you could have also used your angle as your fraction. And if you had divided 7.5 divided by 5 for 12 divided by 8, you should get the same number. You can try that if you want, you don't have to. But that's another way you could have done it. But I think going forward, just stick with this triangle similarity statement. Figure out which two sides. There should be paper towels behind that box. If that's what you're looking for. All right, here we go. On we go. Now the next one's going to be a little tricky. Okay. All right, we look here. This one's probably the hardest example. In more ways than one. Now, okay, don't worry about this box. Put an X through it. But here's the first question. We need to know, what's that angle measurement there? That's what you need to do first. You have a 40 and a 66. So we need to figure out this angle measurement here. So it's just like before. What do we have to do to the first two numbers? If we want to get that third angle measure, what do we have to do with the first two numbers? How'd you get that 74 up here?
You have to add them.
Okay, what do we get when we add these?
106.
Good.
You subtract 180.
180 minus 106. That's what I wanted. Okay, I don't want back here. Sorry about that. '74. All right, now. Okay. Let's look at this triangle. Here's what we have going on here. Do we have a same angle measure? We have the same angle measure at least one time. Okay, we do. Okay, so we have the angle. Now, okay, for the first triangle, we need to figure out, well, actually, depending on how you want to do this, we need to match up some sides. Now, here is where, the idea of a fraction bar triangle. If we decided to do it this way, put your angle in the middle, you can set up your proportion that way. Now, for the first triangle, let's focus on the first triangle. How do you want to set up the fraction for the first triangle? Which number is going on top? Which one is going on the bottom? How do you want to set it up for the first triangle? How do you want to set up that fraction? So just focus on the first triangle. 21 and the 14. This is probably going to be the toughest problem of the bunch. You got a 21 and a 14. How do you want to set up your fraction for just this triangle? Don't worry about this one yet.
21 over 14.
Okay, we can do that. 21 over 14. All right, that's fine. So we have our proportion, 21 over 14. So what about the second triangle? Which number is going to go on top for the second triangle?
9.
Okay, be careful. This is why I'm going to tell you, be very careful with this one. Which number is bigger, 21 or 14? Or longer, bigger? Let's say longer. Shorter. So if you went longer over shorter for the first triangle, you have to do the same thing for the second triangle. This is the one time where I have to tell everybody, be very careful. If you went longer over shorter for triangle number 1, you have to do the same thing for the second. You have to go longer, shorter. So rather than 9 over 13.5, you have to flip it. It's going to be 13.5 over 9. So now another idea which might help everybody. You can always set up your proportion. I'm going to show you something which might benefit everybody. Might be the following. Use the table. You can say longer, shorter, and then you can label it. Triangle 1, triangle 2. Boom. And then right in the middle, you smack an equal sign right in the middle. Oops. So this is triangle number 1, triangle number 2. This might be another way, and I'll draw a better example. When you set up your proportion, using a table might help. Again, that might be another clue to help you. Now, could we have flipped it? Could we have put shorter on the top, longer on the bottom? Could we have done it that way? Yeah, you could have done it that way too. Again, you could have done it
Is that 3?
where?
Oh,
Here, let me fix that. You talking about right here?
yeah.
Oh, let me rewrite that. You got look neater. There you go. And you could have done the same thing. Shorter, long. Longer. Triangle 1, triangle 2. And then set up. Boom. That's another way you could have done your table. Where's your agenda? Take the die, you're there and back. Whatever you miss, it's your own notes. Remember, check your notes with the end of the period. All right. Okay. Well, actually, you can write yeah. Because what happened was we flipped these. We actually flipped it. We did 21, 14, 13.5 over 9. In the end, you should get the same. They're going to be a yes. Because the other way you could have done it. Well, what's 21 divided by 14? What do you get? Who could tell us? 21 divided by 14. Okay, Cindy, calculator, not phone. How much? 21 divided by 14.
Oh, I thought you said.
How much? Okay. What about 13.5 over 9? Okay, so there you go. What happened was they flipped it here. I think it would have been 0.667, I think, or something. That would have been the same here. But then again, yeah, sides are proportional. You have an angle in the middle. So these two sides are proportional. There's your angle. Boom. Side, angle, side. Now, the good news is if you understood this one, it gets easier from here. I think that's the toughest type of problem you're going to see. And then I'll show you what's next. So give everybody a moment to process this information because I know it's a lot. And then from there, we'll figure out. We'll go to the next problem. It gets easier. Trust me, it will get easier. That might have been the hardest problem. Again, it's a matter of making sure how you're matching, how you match your sides. But again, one of two ways. One, look at your, if you have it, similarity statement, or two, if you just have numbers and angles labeled, figure out, okay, triangle 1, triangle 2. Which one's shorter, which one's longer? Or you can flip it. Longer, shorter, and then fill in your table. And especially for the last few problems, you might want to put away that phone and listen up. Last few problems, setting up the table is going to be more important because you may not necessarily know which sides match up with which other sides. All right, I'm going on final questions on this one. Okay, last one real quick. Here's what you're going to do. Take your smaller triangle first. We're going to split this. Now, your bigger triangle, well, we'll say the biggest triangle, and you're going to start from the same, S. But where do you end? If you go all the way down, where do you end? What letter? R. Same thing. You go all the way down. What letter do you stop? T. Okay. Now, here's where we have to be careful. From S all the way down to R. What is the length of that entire length from S all the way down to R? Be careful. Very good. It is 16. No, he's right. It's 4 plus 12. That's what you're going to have to do sometimes. You're going to either add or sometimes subtract. They might say 16 is the length, S to R. They give you the 12. You have to get 4. Okay, now from S to T, what's the entire length from S all the way down to T? 20. So again, you're back to your set up your little chart. Triangle 1, triangle 2. Or no. Actually, I think no, they flipped it kind of. All right, time out. What they did was they did triangle 1. This is another way you can do this. Triangle 2. Then they went, this is another way you could set up your short, long. So for triangle 1, what was your shortest side? For triangle number 1, or we'll say the smaller triangle. What's your shorter side? Look at the small triangle. 4. And then for the big triangle.
15.
Triangle 2, shorter side.
4.
That's for triangle 1. What about triangle 2, the big triangle? What's your shorter side? 16. 16. And then triangle 1, which side was longer, 4 or 5? Other one? What's your longer side? Okay. So then, here's your setup. Boom. There you go. So you can do 4 over 16, 5 over 20. Both cases, what number should you get? What number are we going to get here? 125. You could have done the other way. You could have did the crisscross multiplication. 5 times 16, 80. 4 times 20, 80. That would have worked too. So, do we agree the sides are proportional from one triangle to the other? Do we agree? Okay, so the sides are proportional. Got an S, got an S, S and an S. Now, what about our angle? What do we know about the angle for both triangles? What do we know about that angle on the very top? What letter is it? S. So that means we started at the same angle. So since you shared that angle on the top, you automatically have a side angle side angle here. Now don't worry about this RST-PSQ, but they're congruent because it's shared angle. These two angles shared. Basically, you took the same angle, you just did top of the iceberg, and then the whole iceberg. That's what you had going on here. So in the end, you have a side angle side. Two sides, angle in the middle. There you go. So that's another way to determine a side angle side. If their angle on the top shares both small and a big triangle, that angle measure never changed. This angle measure on the top did not change for the two triangles. Same one. All right, questions on this one? Now the last one, the proven triangles are similar by way of the side, side, side. Believe it or not, you've done it already. You have actually done it. Think about your quiz. Remember your quiz recently, Dennis? Cindy, you remember your quiz from last time? Have we figured out whether or not two triangles were similar? We've kind of seen this already. It's all about setting up your proportions. Either given triangle statement or you're going to be pairing off your sides. Shorter side, smaller side, medium, longest side. That's what we have going on here. So basically, you're pairing off your sides. So if you get a similarity statement, if you get your letters. Now this was one way. They just showed you sides. They basically said, maybe the shorter side, AB, BE, you pair them off. Then the medium side, BC, EF, pair them off. And then the longest side, DF, AC, pair them off. But remember, you have to set up, always set up your chart. So if I'm going to teach you all one thing, set up your chart. So we could always say smaller triangle, larger triangle. And then you set up your chart like this. Shortest side, medium side, longest side. If you want the quickest way to set up any of these proportions, you can use this chart. That might be the quickest way for you to figure out. Because then, you always put equal signs. Equal sign, boom, there's your fraction bar, fraction bar, fraction bar. So that might be the quickest way. No matter what triangles you get. That might be the quickest way for a side deal. Again, all three sides from one triangle have to work with all three from the other. And again, you can flip this. You can switch these two. You can say smaller on the bottom, larger on the top. Look at what's given to you. You can do that too. These can flip. You can even say largest, medium, smallest. That's fine too. Or you could have the middle, largest, smallest. But as long as you're consistent, you've got to be consistent. That's going to be key. If you're not consistent, then the mistakes happen. So you have to be consistent. All right, questions, anybody, before we continue? Okay, here we go. All right, this one. Which triangle do you see first, the larger or the smaller triangle? Larger. Now, in this case, they told you which sides. Give you larger, smaller. Now, what we did was the following. For the first triangle, we kind of went this direction. So I'm going to cheat a little. So we started with LM, which is 26. But then LM is going to match up with OQ, because we kind of went in this direction. Now, if you had went PQ, PQO, that could have been okay. So we can say that's your shortest side. And then the medium side. Now, if two numbers are the same, does it matter who was the shortest side? If the two numbers were the same, if they're both the smallest? No. That's why this one, you could have gotten away with it if you went LMN and PQO. You could have gotten away with it. That's why this is not my favorite example in hindsight, but QP. So the small and the medium. MN, that's 26, 26. Now, but we do know one thing for certain. So if you go with the longest side, largest side, for the big triangle, what's our longest side? You can tell us what's the longest side.
Oh wait, actually
30
30.
in L. That's your longest side. Similarly, what's our longest side in our other triangle?
15.
15, PO. So this could have worked. Now, you could have gotten away with flipping these two because they're still going to pair off the same. Now, in all three cases, if we simplify 26 over 13, 30 over 15, all three cases, what's our final result?
What?
Divide. Just divide the numbers. What do you get in all three cases? That's simple. Everybody should be doing this. I don't know why I see closed calculators. You're gonna get 2. All three cases. When you do your simplification, it goes down to the same number, 2. So, since they're, in this case, the sides match. So what type of similarity statement do we have? You have your side, side, side. That's what you have going on here. That's how you set up the first one. Now, when we do our other 3, similar idea. Set up your proportion, or they might give it to you, because I think the second one they gave it to you. But again, there's not one specific way to set up your proportion. So if we look at number 2, all right, well, the next problem, well, before we get to that, any questions on the first problem about matching this?
No, Stephanie.
Okay, look,
Go.
not a problem, come on. Okay. Sides of the first triangle matching with the sides of the second. And many times you're going to see who's going to match with whom. Like with this example, again, okay, triangle 1, triangle 2. Bigger, smaller. Now in this case, we went with longest side, medium side, shortest side. You could do it in any order. Again, for the first triangle, what's your longest side? What's the largest number? What's the biggest number? 36, 30, or 12? Medium side. 36 is the largest. What's our middle number? What comes next?
30,
Then?
12.
All right, boom, boom. Triangle 2, longest side. Who's our longest side?
24,
Then,
30,
then.
8,
All right. Now the typed example, they just switched these two. But in all three cases, if you simplify 36 over 24, 30 over 20, 12 over 8, what do you get in all three cases? You get 1.5 for 3 over 2. So these we've actually done before. Since in all three cases we get 1.5 or 3 over 2, can we say we have a side deal going on here?
We need to stop a little bit. Yeah, okay.
So do our three sides match? Yeah, they're going to match. All three cases, you get 1.5. 1.5, 1.5, 1.5. Boom, done. There you go, side, side, side. Questions? Should be on the last page. Okay,
Wait, can you move back to the first?
hurry up.
What was the last bar?
Triple S. All right, here, what they did, they did the smaller triangle over larger triangle. So you could take triangle 1, triangle 2. But then they went longest side, medium, shortest. That's what they have going on here. So for triangle 1, which is the smaller triangle, what's our longest side? Look at the top triangle. Okay, then it's 21, then, okay, what about the bottom? Longest side on the bottom, triangle number 2. Then, okay, all 3 cases, what should you get when you simplify or divide? 0.5. So in all 3 these boxes, you're going to get 0.5 all 3 cases. Boom, boom, boom. Zero five, 0.5, 0.5. And again, what do we have here? That's our, so we compared, what did we compare? Sides or angles in all 3 cases? Sides. Side, side, side. There you go. All right. Now, last one. When we're ready, did we write that down? Okay, for the last one. But after we do this last one, don't wrap it up yet. Because we can talk about some homework problems and then you might actually be halfway done with their homework by the time the bell rings. Do we want to have less homework this weekend? Okay, so. All right. Really quick for this one. Our smaller triangle. For our smaller triangle, all 3 sides add up to, are what number for all 3 sides? 4. Boom, boom, boom. Then for the larger triangle, all 3 sides for the larger triangle are what number? Be careful. Larger triangle. It is 6. You gotta add them. It's on the bottom. Gotta be careful. 6 on the top, 6 on them sides. Boom, boom, boom. It's 6 in all 3 cases. Good. Remember, 4 plus 2 is 6. 4 plus 2 is 6. And since all 3 sides from the first triangle are the same as all 3 sides from the second triangle, they're automatically going to be similar triangles because it's side by side. Because you can multiply same number or divide by the same number from going from one triangle to the other. So boom. Side, side, side. There you go. All right, really quick, you might want to, before we wrap it up, we'll talk about a couple homework problems. Because guess what? You might want to listen. You want to have at least half your homework done? If you don't, let me know. All right, here we go with the homework real quick. Everybody should have a copy. So if we look at some of these problems, what we need to do, first of all, and I'm going to be honest, you're going to know right away. Because number one, in all three cases, what are we given? What are we given for both? No. Look at number one. What's given to us? Are we given sides or angles? So similarity criteria has to be side, side, side. Now, ABC, medium, largest, smallest. You have to do the same thing. You can start medium, small, largest, smallest. So, where are we going to start? You got to be careful here. Say again? RP2, very good. You got to do the same thing. Medium, largest, smallest. That's what we have to do with these types of problems. Okay, number two. Similarity criteria. Well, what's given to us? Got a side, angle, side.
Yeah.
That's a side, angle, side. So we went from RST to this triangle. Where do we have to go? Where do we start? LMK. You have to start at the smaller side, go to the turning point, angle, boom. LMK. That's number two. Then, skip down to number 4. 3 is just like 2. Go to number 4. Well, by process of elimination, which criterion? Just angle, angle. There is no angle, angle, side for the similarity. Angle, angle, just 2 angles from one triangle match with 2 from the other. That's all you need to know. Then, we go from STU. 0, 1, 2. Our other triangle. What letter must we start? WXV. You gotta be careful. WXV. So let's not start 0, 1, 2. With 0, 1, 2. Got to be careful, ladies and gentlemen. All right. Recording, you gotta go up. Congratulations, you're already halfway done with your homework.
Keep the notes.
What's that?
We keep the notes.
Yeah, keep everything. I know who was here, so you're gonna get credit for your. Yeah, you gotta keep that one. Since I know who was here, I know who's gonna get credit. Okay, Stinger 5, have a great weekend. Bring it back next time.
Okay, thank you, Mr. Connor.
All right, thank you, Mrs. Madden. Have a great weekend.
All right. You too, thank you. The way we can.